Welcome everyone. So here we meet again on our another session on structural analysis. GATE Super 11 structure analysis. So join fast, quick everyone. We are about to start. Very good afternoon to all. Very good afternoon everyone. So let me introduce myself. My name is Rohan Goyal everyone, and I have a master's degree in structural engineering from IIC Bangalore. I have an All India rank of 96 in GATE 2020, and these are the subjects that I teach at that I teach at BYJU'S. And other than these, other subjects as well. Welcome. Good afternoon, everyone. Good afternoon, Raja. So, did you like the yesterday session on strength of material? Today as well, we are going to be discussing some of the very important questions from our structure analysis subject. At least 4 marks will be asked in the GATE examination. 4 to 8 marks. The marks varies from 4 to 8. Good afternoon. Harita, Kalyani, Mayank, welcome. Welcome guys. Welcome everyone. Good afternoon, Lavanya. Welcome. So, let us start. And before starting, this is our schedule that has been going on already. So, we'll be completing structure analysis today. And tomorrow, Ansari sir is going to be joining you at 3 p.m. again. And he'll be taking fluid mechanics. So, do not forget to watch that session as well. Fluid mechanics, railway, airport engineering. See, this topic, do attend this session. Okay, this session is going to be a very important session for you. This session is going to be a very important session for you. Over here, Ansari sir is going to be taking 11 questions for you guys. And the question which is going to be asked in the GATE examination, if asked, will be out of those 11 questions only. Okay, because there are not too many questions that could be framed from this particular subject. So do not forget to attend this session. Okay, and at the end, Krishna sir will be taking your environment, right? So let us start. SOM weightage, yeah, it is around 4 to 6 marks on average, but you cannot say for sure that it will be this much only. Okay. Welcome, join fast, quick. We are about to start. So let us start with the today's session. What is this? All right. Here is the first question. Read the question carefully. Very good question. A planar truss tower structure as shown in the figure, consider the following statement about the external and internal determinacy of the truss. So you are given a truss over here. You are asked to comment upon the external and internal determinacy of this given truss over here. Now, few students may get confused, sir, what is external determinacy and what is internal determinacy? Now, if you imagine your body, now you are standing still over here, right? So what are the external reactions you are getting on your body right now? If you are standing like this, the external reaction that I am getting is from the ground below. There is a normal reaction from the ground below, right? Over my foot, right? That is the external reaction. So if suppose I have skates, if I am wearing skates, if there is some horizontal reaction, what will happen? The skates will go ahead and I will fall down. So at a roller support, I have to balance as if that there should be only a normal reaction downward. So if a horizontal force is there, I will fall, that means instability will occur. So the number of external reactions are accounted by the external determinacy. And what do you mean by internal determinacy? Internal are the number of bones. You are having bones in your body. If one of the bone is missing, I am lifting up this remote over here. If suppose this bone is missing over here, will I be able to lift this remote? No. It will behave like a rubber. My arm will behave like a rubber. It will be inefficient to lift any weight at all. So this is your internal determinacy. Okay. Similarly, over here for this truss, the external determinacy will be the number of unknown reactions that are externally. So we are having two pinned spots over here. So there will be one vertical reaction, let us call this as A, and let us call this as B. So there is a vertical reaction at A and a horizontal reaction at A. And similarly there is a vertical reaction at B and a horizontal reaction at B. Okay. So what are the number of unknown reactions? 4. So degree of external indeterminacy is given as number of unknown reactions minus number of equilibrium equations. Number of unknown reactions 1, 2, 3, 4. 4 number of unknown reactions. Number of equilibrium equations. How many equilibrium equations do we have? We have 3 equilibrium equations. Summation of forces in the horizontal direction, summation of forces in the vertical direction, and summation of movements at every point. So our external indeterminacy is 1 degree. So that means the structure is externally indeterminate by 1 degree. Yes or no? Now internal indeterminacy is how many extra members, redundant members is this truss having? How many redundant members is this truss having? This is given by the formula M minus 2J minus 3. Where M are the number of members, let us count the number of members. So I will count the number of members. So let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So we have 11 number of members. 11 minus 2 times number of joints. How many joints do we have? We have one joint over here. Let us write it as 1, 2, 3, 4, 5 and 6. So 6 joints we have. 2 into 6 minus 3. So this will come out to be equal to 11 minus 12 minus 3 is 9. 11 minus 9 is 2. So the degree of internal indeterminacy is 2 degree. So the answer is Q and U are correct, rest all are false. So you are asked to tell which of the following options is the right answer. So P is false, so Q is true. So we are having Q true in these 3 statements, and then we are having U true. U is true over here and over here. So we are having 3 options. No, we are having 2 options. So this is not possible. Okay, and this is also not possible. So A and D. Now look over here P is also true and S is also true, which is also false. So the answer is A. A is the right answer. Any doubt to anyone? Any doubt to anyone in this particular question? Very easy question and a very probable question also. Such type of questions are repeatedly asked based upon determinacy. Very repeatedly asked, guys. Very easy questions. Just study the indeterminacy chapter once if you have not studied it yet. study the degree of static indeterminacy and kinematic indeterminacy, how to find those, okay, for beams, trusses and frames. Next, the degree of static indeterminacy of a rigid jointed frame PQR supported as shown in the figure. So you have to find out the degree of static indeterminacy for this particular frame. So over here it is given to you, this is cable and this is your rigid frame. Let me make this a little thick over here. No. All right. So you are given a frame PQR, okay, PQR, and this RS is given to you as a cable. RS is given to you a cable. Now, what will be the first of all degree of static indeterminacy is asked to you, okay. Now, beams are always internally determinate. Okay, the degree of internal static indeterminacy is always 0 for beams. Okay, so only we are going to have is external indeterminacy. So external means number of external reactions that are applied by the supports, external supports. So what are the supports that we are having? We are having a pin over here and a pin over here. Now at a pin support, what we have said it is, you are going to get two reactions. One is going to be horizontal and another is going to be vertical. So as per your knowledge, what you are going to draw is, you are going to draw a horizontal reaction at P and a vertical reaction at P. And similarly, you are going to draw a horizontal reaction at S and a vertical reaction at S. So when you do such a thing, this is where you make a mistake. Okay, so over here, are these two unknowns? Are these two unknowns? This is the question. So over here, when we write the equation, degree of static indeterminacy is equal to number of reactions minus number of equilibrium equations. R are your unknown reactions. These are your unknown reactions. So are these two unknown? So the point over here is, this there is a cable, and the cable is only able to take axial forces. Okay, it can only take axial forces. So this cable can only be stressed axially. It may be tension, it may be compression, whatever it may be. I'm just taking an example. So the cable is only able to take axial forces. So if it is only taking axial forces, the reaction which is going to be offered over here will also be along the direction of the cable. Yes or no? Yes or no? The reaction that I'm going to get over here, will also be along the direction of the cable at an angle of 45 degrees. Yes or no, everyone? Yes or no? Do you understand this concept or not? Yes. All right. So if we know the direction of this reaction R at this pin support, don't we know what is going to the horizontal and the vertical components? R cos 45, R sin 45. Don't we know the horizontal and vertical components? And if we know the horizontal and vertical components, are they unknown? Are they unknown? No. So over here, the only unknown reaction is R. So what are the number of unknown reactions? 1, 2 and 3. So the degree of static indeterminacy is number of unknown reaction are 3 minus 3 equilibrium equation. So it comes out to be statically determinate. It is a statically determinate. So the degree of static indeterminacy is 0. A is the right answer. Very good question. You need to understand the property of a cable. That is all it is tested in this question. Moving on. A long uniform distributed load of 10 kilonewton meter and a concentrated load of 60 kilonewton are moving together on a beam ABCD shown in the figure and not drawn to the scale. The relative positions of the two loads are not fixed. The maximum shear force in kilonewton, rounded off to the nearest integer, caused at the internal hinge B due to the two loads is. So basically it is asking us what is the maximum shear force that is possible at this hinge B due to these two loads, a point load 60 kilonewton and a UDL of 10 kilonewton per meter. So what do we need to do? We need to draw the ILD for shear force at B. In order to draw the ILD for shear force at B, we cut the section at B and we lift the section by unit 1 by Mueller's-Breslau principle. So this is unit 1. Okay. So you will get an ILD for shear force at B will be this one. This will be the ILD. This itself is the ILD. This can be positive or negative. Okay. Shear force can be either positive or negative. Okay. The sign is not mentioned what we have to take, but we will answer in positive only. We will not consider negative. So now where should you place your UDL? Your UDL will come like this for the maximum shear force at B. Okay. And further your point load will be at the maximum value over here. So a 60 kilonewton will be placed over here and 10 kilonewton per meter will be placed over here. Okay. Now what will be the shear force at B? Will be equal to UDL into area of this triangle half into base is 2 meters plus point load into the distance below the point load of ILD. So 60 into 1. So this will be equal to, this will cancel out, this will become 10 plus 60, which is equal to 70 kilonewton. So the answer is 70. Any doubt? Any doubt to anyone? Any doubt to anyone? Very easy question. All you need to know is how to draw the ILD. Rest all is very easy. Next question. The influence line diagram shown is for the member. So you are given 4 members, PS, RS, PQ, QS. So which of the 4 members the influence line diagram is shown for? Tell me. Very, very good question. Very good question. Tell me. Tell me, guys. Tell me. What is the answer? So over here, the examiner is testing whether you know how a truss behaves. See, in order to find out the ILD, you have to, the student may think, sir, I have to check each and every member over here in order to tell which of the following is the ILD for this member, right? So I have to test each and every member over here. That is not possible because testing for even a single member takes a time. At least 5 minutes time is required to test, to draw the ILD for at least one member. Okay, and here I have to draw for 1, 2, 3, 4, PS, PQ, QS, and whatever, which of these is not there. PS is there, RS is there, QS is there, PQ is there. So this one is not, PR is not there, right? So 4 members are there. 4 members are there. So it is not possible to draw the ILD for each and every member and then tell which of the following member this ILD belongs to. Okay. So how is this solved? See, you need to understand that the behavior of the truss is similar to that of a beam. The behavior of the truss is similar to that of a beam. Imagine this as a beam. What happens in a beam? What happens in a beam? When a movement is applied, let us, for example, take an RCC section. Okay. So we have compression steel, we have tension steel, and shear reinforcement. So in order to resist this movement, the top reinforcement will take compression, the bottom reinforcement will take tension, and this diagonal will take shear. Yes or no? Yes or no? Similarly, over here as well, the top chord members of the truss are due to any load over the truss. See, load is moving over the truss. Due to any load on the truss, the top chord members are under compression and the bottom chord members are under tension. The top chord members are under compression and the bottom chord members are under tension. And these diagonal members are subjected to alternate compression and tension, depending upon the location of the load, whether the load is over here, where it is. Depending upon that, it will be subjected to alternate compression and tension. So over here you can see, depending upon the location of the load, there is compression as well as tension. So which of the four members is this ILD belonging to? Obviously the diagonal member, that is PS. The answer is A. Isn't this an easy question? All you need to know is the behavior of a truss. All you need to know is the behavior of the truss. Moving on to the next question. Another very good question. It has been, this concept has been asked in various questions, right? All members in the rigid jointed frame shown are prismatic and have the same flexural stiffness EI. Find the magnitude of, this question is incomplete. Find the magnitude of movement at support Q. Okay, find the magnitude of movement at support Q. So what will be the movement reaction at Q, it is asked. So the movement of 100 kilonewton meter is acting at a rigid joint T. So this 100 kilonewton will be distributed to all the four members depending upon their distribution factors. So you must have studied distribution factors, which is the stiffness of a particular member divided by summation of the stiffness of all the members. So let us write down the stiffness factors for all the members. We will have member K and distribution factor. So members we are having TP, TQ, TR and TS. TP we have far end is hinged. For a far end hinged, the stiffness factor is 3/4 I by L. If you do not know these values, then you need to go through the basics again. Okay. So 3/4 I by L. L is, this is 3 meters, this is 2 meter, this is 4 meter, and this is 2 meter. So L over here is 3 meters. So I will substitute the value. 3/4 I by 3. So this will be cancel out. This will be I by 4. TQ is far end is fixed. So I by L. So I by L is 2. TR again far end is fixed. I by L. I by 4. And TS See, far end is free. If the far end is free, do you require any movement to rotate this? No, it will freely move. Suppose if we have a pin support like this and the far end is free, without any load it can go like this. So it required zero movement. Zero movement is required. You require a zero movement over here. Okay. So the stiffness factor for this TS is 0. So what is the summation of stiffness factors? I by 4 plus I by 2 plus I by 4. It will come out to be equal to I. It will come out to be equal to I. So what is the distribution factor for each? It will be equal to K divided by summation of K. So I by 4 divided by I is 1 by 4. One by 4, 1 by 2, 1 by 4 and 0. But we are only interested in TQ. We are only interested in TQ. So the distribution factor for TQ is 1 by 2. If the distribution factor for TQ is 1 by 2, then this TQ member will be taking a moment equal to 300 by, 100. Will be taking a moment of 100 by 2, which is equal to 50 kilonewton meter. But this is the moment which is going to be resisted by this member TQ. But what will be the reaction at Q? Which is equal to the carryover moment. If there is 100 over there, the carryover moment will be 50 by 2, which is equal to 25 kilonewton meter. So the answer to this given question is 25. The answer to this given question is 25. Okay. What if S has a roller support? If S has a roller support, still it will not be able to resist any movement. And further, it also depends upon the location of the movement, location of the roller. See, if the movement is applied like this, so if the roller is provided like this, it will provide a reaction. And there it will behave like a pinned then. It will behave like a pinned, like this only. But if it is like this, if it is some other location, so it depends upon the reaction. It depends upon the reaction. Okay. Moving on to the next question. Moving on to the next question, everyone. Very good, guys. Very good, everyone. Next question. Another very good question. Okay. Again, this type of question has been asked at least 2 to 3 times. At least 2 to 3 times in the GATE examination. So that is why I am taking this question, and I also want to address one very good doubt, very good concept over here. A right triangle truss is made of member having equal cross-sectional area of 50 mm square and a Young's modulus of 2 into 10 to the power 5 megapascal. The horizontal deflection of the joint Q is, what is the horizontal deflection of the joint Q? It is asked to you. What is the horizontal deflection of the joint Q? So what are you going to do? What are you going to do? You are going to use your formula. The deflection at the horizontal deflection at Q is equal to summation of PKL upon AE. Where? So I will draw the table. Member. So let us take the member PQ and first of all, K value, P value, okay. P and L. Okay, and based upon that we will find out PKL upon AE. Okay, now for member PQ, see, K is a load which is going to come in this particular member due to a unit load applied in the direction of the deflection in which you want to calculate the deflection. So you want to calculate the deflection in the horizontal direction at joint Q. So you will apply a unit load in the horizontal direction at the joint Q. Due to this horizontal load at the joint Q, what are the reactions in the other members? That is required to be calculated. So if you see over here, this is 4.5 and this is 6. And this is a right angle triangle. What is 4.5? 3 times 1.5. What is 6? 4 times. 4 times 1.5. Don't you see something similar over here? 3, 4. What is it? It is a magic triangle. So this is 3, 4. This will be 5 times 1.5, which is equal to 7.5. Right? Okay. Now, if this is 1, there will be reaction. So 1 is acting in this direction. So you require a resistance in the opposite direction. So this will be acting in the opposite direction like this. If this is acting in the opposite direction like this, there will be a reaction, a component of this reaction in the downward direction. So over here, the reaction will be like this. Okay. Similarly, like this. Like this. Now see, this reaction is in the upward direction. So the component will be in this direction. So if the component is in this direction, we require a resistance in this particular direction. So it will be like this. Now, there is a one note point over here. This member over here will show reaction only in the case when there is a roller support over here. If in case this is the pinned support, there will be a zero reaction in this member. This will be a zero force member in that case. Why? Why? If this is pinned, if these two supports are pinned, that means they are fixed at the location. If I have a pen in between and I have two supports which are fixed. Now, if these two supports are fixed, will this member will ever be stressed? Never. Why? This will get stressed only when there is some deformation. If this is a roller, now if it wants to go in this direction, but this member is pulling it backward, so it will be under a stress because it is providing some resistance. Only because there is a roller over here. But if it is a pinned, then it will not be stressed. It will be having a zero force. So once a gate has also asked a question and he has given a pinned supports at both the ends. So you just pay attention to the supports. Okay. Over here, since a roller is there, you will get a reaction over here. See, I have done my calculations. Okay. And I will give you straight away the reactions. I have done my calculations and I will give you straight away the reactions to save some time. Okay. So if this is 1, then this will be 5 by 3. And this will be 4 by 3. And this will be 1. So I will write down for PQ. PR and QR or RQ. Okay, so K value will be for PQ. It is, we will take tension as positive and compression as negative. So this is in tension, 5 by 3. PR is in compression, 1 minus 1, and QR is also in compression, minus 4 by 3. Now, if for 1 unit load I am getting 5 by 3 unit load in this member, then how much will I get for 135? So it will be 135 multiplied by 5 by 3. So it will be similarly minus 135. Right? and this will be minus 4 by 3 multiplied by 135. Try to save your time. Understand this unitary. Okay, how the units are working. Length is for PQ 7.5, for PR 4.5, and for RQ 6. Now multiplying PKL, AE is given over here. AE is given over here, and substitute all the values and find your summation. Your delta is equal to summation of all these three. Delta is equal to summation of PKL upon AE. If you calculate this, the answer that is going to come is 15.68 mm. Understand the concept. Very good, Raja. Very good. You will get 15.68 answer. Understand the concept. Okay. So do you understand? Any doubt? Any doubt to anyone? Tell me, guys. Any doubt to anyone? Is it clear to all? Is it clear to all? Is it clear to all? Let us proceed. Carryover factor CAB for a beam shown in the figure below. I am expecting this kind of a question again. Carryover factor CAB, it has been asked only once, and I am expecting a question similar to this one again, because students are going to get confused over here. So what is CAB? CAB. So this is carryover movement So you can write down is equal to carryover movement at B divided by applied movement at A. All right, is it clear to all? Carryover movement at B due to applied movement at A. Let us say you apply a movement M over here. So what will be the carryover movement at B? It is asked to you. What is the carryover factor? Sorry, carryover factor at B. So let us divide the particular beam at the hinge. So, and let us draw the free body diagram. And this is your hinge. Okay, is it clear? Okay, now movement is applied over here. Now what is the bending moment at the hinge? What is the bending moment at the hinge? What is the bending moment at the hinge? 0. The bending moment at hinge is 0. So it will only take your reaction. So due to this movement is acting in the clockwise direction. In order to resist this, a couple will be generated in the anti-clockwise direction. The length of the member is L. So a couple is going to generate in the anti-clockwise direction. So anti-clockwise, see, anti-clockwise. Movement is M in the clockwise direction. There is a couple in the anti-clockwise direction, whose magnitude is any doubt? Any doubt? Check whether the movement at this hinge is 0 or not. It is going to be 0. Now, if a reaction is acting in the upward direction at this hinge in this free body diagram, then on this particular end, if there is acting in the upward direction, over here it will be in the downward direction. For equilibrium. Okay, equal and opposite. Now if there is a downward m by l acting, so the movement over here is in the anti-clockwise direction. This m by l is providing a movement in the anti-clockwise direction. So the resistance will be in the clockwise direction, whose magnitude is m. Yes or no? Yes or no? Is it clear or not? Is it clear or not? Yes, everyone. Tell me, guys. So what is the carryover movement at B due to applied movement at A? See, the applied movement at A is clockwise. So let us write clockwise as positive and anti-clockwise as negative. So the carryover movement at CAB will be equal to applied movement at A plus M. Carryover movement at B, clockwise plus M. It will be equal to plus 1. So the answer is D. The answer is D. The answer is D. Is it clear to all? Any doubt? Any doubt to anyone? Is it clear to all? Yes, everyone. If lengths are different, then the calculation will go accordingly. What's the issue? If the length is different, then the calculation will go accordingly. What I have done over here, the only thing that I have done is I have used the equilibrium equations. Okay, I have given the equilibrium equations in a short manner. I have explained the equilibrium equations in the short manner. If the lengths are different, you can use the equilibrium equations and solve accordingly. Very easy. Next question. Consider the Potter frame shown in the figure. Assume the modulus of elasticity as 2.5 into 10 to the power 4 megapascal. The moment of inertia is this. For all the members of the frames, the rotation in degrees. See, degrees. The student will give the answer without considering this fact. Up to 1 decimal place. At the rigid joint Q would be. Read the question twice in your examination. While attempting the examination, do not be in a hurry. Okay, write this on a sheet of paper and paste it in front of your study table. Right? That read the question twice. Read the question twice. Every time you study a question, read the question twice. Okay? Right. Now, over here you are given a frame and the loading is only given on this particular part. This freestanding wall over here. Now we are asked to find out what is the rotation of this joint Q. What is the rotation of this joint Q? So in order to find out the rotation at this joint Q, what I am going to do is I am going to first of all see what will be the equivalent movement due to this. So see what is the movement at Q? Let us take clockwise positive, anti-clockwise negative. Clockwise 1650 into 2 square by 2 minus 2000 multiplied by 2. Solve and tell me what is the value you are getting for the movement over here. Minus 700 minus so what I am going to do, I am going to apply a anti-clockwise 700. Now all I need to do is analyze this particular problem over here. Let me show. So I am going to erase this particular part. Okay. And now I am only interested in this particular portion. Okay. All right. Now I am only interested in this particular portion, 700. Check these two members, QS and QR. Check these two members. Both of the members are having same stiffness EI. Both of the members are having same stiffness EI. Both of the members are having same length, 4 meters. Don't you think that both of the members are having the same stiffness EI by L? If both of the members are having the same stiffness, this 700 is going to be distributed equally in both the members. This 700 is going to be distributed equally in both the members. Right? So the rotation in any particular member is due to, at this joint Q, will be due to this 350. So all I need to analyze is this one. So this is Q and this is S. So what is the rotation? Theta at this joint Q due to this 350 kilonewton meter. So the theta at Q is equal to ML upon 4 EI. These are your basic formulas. M is 350 kilonewton meter converted into Newton mm multiplied by L. L is 4 meter, 4000 mm divided by E, 2.5 into 10 to the power of, this should be, I guess, 5. I'm not sure this. Let us take this 4. 10 to the power of 4. Plus. Not plus, sorry. Multiplied by I. 8 into 10 to the power of 8. And this 4 is also there, right? 4 multiplied by. Now this is in degrees or radian? This is in radian. So you have to convert it into degrees also. Multiplied by 180 by pi. Now this you are going to get in degrees. Tell me what is the answer you are getting over here. Calculate and tell me the answer. Calculate and tell me the answer, everyone. Calculate and tell me the answer, guys. Calculate and tell me the answer, everyone. Yes, everyone. Calculate and tell me the answer. You're going to get as 1.002 something, 1.002 degrees. So round it off to the first decimal place, so it will be 1.0 degrees. The answer is 1 degree itself. The answer is 1 degree itself. Check your calculations, Harita. Check your calculations. PM, yes, your answer is right. Mayank, you also need to check your calculation. All right. Next question. Next question. This is also a similar type of a question that we have studied just. Mathematical idealization of a crane. So this is the mathematical idealization of a crane. This is a crane, model of a crane. How we study in books. Okay, how we study in books. How we deal with the complex problems in our books. This is the crane problem. Mathematical idealization of a crane has 3 bars with their vertical arranged as shown in the figure with the load of 80 kilonewton. Hanging vertically. The coordinates of the vertices are given in the parentheses. The formula in the the force in the member QR. So this is Q This is R. There is one roller support over here, guys. This is a roller support. This is a roller support. The forces in the member QR will be F force in the QR. The two hinges at the bottom named Q and R with coordinates 1 and 0 and 3 and 0 respectively. So guys, you are given the coordinates of these two coordinates and you are asked to find out what is the force in this member. So you can use the sine rule. You can use the sine rule. So if at any given joint, three forces are there. Let us call this as F1, F2 and F3. This is theta 1, this is theta 2 and this is theta 3. So sine rule says that F1 upon sine theta 1 is equal to F2 divided by sine theta 2 is equal to F3 divided by sine theta 3. This is your sine rule. Using sine rule, you can easily calculate. So what you can do is, first of all, you can do summation of moments at R is equal to 0. So you have a reaction. You have a reaction at Q, a vertical reaction at Q. Okay. So using this, you will find VQ, vertical reaction at Q. After finding the vertical reaction at Q, once you know the vertical reaction at Q, you can use the sine rule and easily find out the reaction in QR. Okay. So this is your homework problem. You will get the answer as 30 kilonewton in compression. Okay. Next question. A plain truss with the applied loads is shown in the figure. The nodes are intersecting at HR. The node at the intersection of HR and JS is named as U. This is U. This node is U. And the node at the intersection of K, R and JQ is named as V. So this is V. The members which do not carry any force, that is zero force members, is asked to you. Zero force members are asked to you. Very, very, very popular question for GATE. Zero force members. So you need to know two principles. There are two cases. Case 1. When do we have zero force? When do we have zero force members? Case 1. When there are two members which are joining at a joint. When there are two members which are meeting at a joint at some angle theta. At some angle theta. When there are two members which are joining at a joint at some angle theta and there is no force upon this joint, then both the members are zero force members. Okay. When there are two members meeting at a joint without any force, then both the members are zero force members. Case number 2. When there are two members which are in a single line and there is another member which is perpendicular out of this line, then this third member will always be a zero force member. This third member will be always a zero force member. Why? You need to draw the free body diagram. Very easy solution to this one, very easy reasoning to this one. So all you need to do is the free body diagram. I have just given you the gist of it. Let us use this principle over here. Let us use this principle over here. Okay. Now if you look at this member FT, see over here EF and FG are linear and this FT is out of the plane. So this will be a zero force member. Are you able to see the diagram? Yes or no? Are you guys able to see the diagram? Yes or no? So this is going to be a zero force member. Now if this is a zero force member, then this ET and TS are linear and this TG is out of the linearity. So this will be a zero force member. This will be a zero force member. Further, similarly over here also, this is a zero force member and this is a zero force member. Further, if you look at this particular joint over here, H joint, GH and HJ are linear and HU is out of the line. So this is zero force member. But this is not the case over here. See, over here at K, we are having a 10 kilonewton over here. So this is not a zero force member. This HV is not a zero force member over here. This HV is not a zero force member over here. So what are all the zero force member? FT. So this is not the answer. FT and FT. TG. TG. So this is also not the answer. TG. TG is not here. Okay. TG. HU. 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 MP and PL. So A is your right answer, guys. A is your right answer. So with this, we wind up our today's session. Do like the session, guys, if you like the session, and share the session with your friends, and do download our BYJU'S Exam Prep app. And that's all for the session, everyone. Tomorrow also another subject at the same time, at the same channel. Thank you, everyone. Goodbye and see you in the next section, guys. Bye, everyone. Take care.